I'm going to do another example that is similar to our last one, but a little bit different. So here we go. We're going to find the slope of the tangent line to f of x is equal to x squared minus 2x plus 4 at an x value of -3, -1, 0, 1, 3, 5, and also 25. All right, so the idea here is that I can use my limit definition of a derivative, which says we want to calculate the slope of the tangent line. I can use my limit definition of a derivative, which says that the limit as h goes to 0 of f of a plus h minus f of a all over h. And I can do this separately for each of my, actually we'll call these a values. I can do this separately for each of my a values. Run through the calculation for -3, and then run through the calculation for -1, and then 0, and then 1, and that's going to be a big pain in the neck. So we want to do this for a generic letter. Okay. Now, last time I said let's do this for a generic x is equal to a. This time, I'm going to change this a little bit. Rather than talking about a, these a values are really just x values, so why not just call them x? And so if that's what I'm doing, if I'm calculating the derivative at a particular x value, then really what I'm doing here is f of x plus h minus f of x over h, and then taking the limit as h goes to 0. And so I'm swapping out that a for what a really is. A is a number, but it's truly an x value. So I'm just going to call that value x. Okay, so let's calculate f prime of x for a generic x. All right, so looking at this limit, we've got our definition up here, our limit definition of a derivative. We've got to fill in the pieces. So we've got f of x plus h. And so in terms of our example, we're looking at the function f. And everywhere I see an x, I'm going to replace that with an x plus h. So we've got x plus h squared minus 2 times the quantity x plus h plus 4. And the other part of my numerator is f of x. So I've got f of x is equal to x squared minus 2x plus 4. All right, so I'm going to fill in these pieces. Before I fill them in, are there any questions?
May I ask once you want to get the slope of this, what you have to do is plug in those x values to the slope you're going to find?
So in the end, what we're going to do is we are going to end up with f prime of x, which will be a formula,
right,
which once we have that formula, we can plug in x equal to -3, and it will tell us the slope of our curve when x is equal to 3. Or we can plug in x equal to 1, and that will tell us the slope of our original function when x is equal to 1.
Oh, it's not going to be the same slope.
So it's not going to be the same slope because our curve is going maybe all over the place.
Sorry.
Okay, other questions so far? Okay, so let's fill in our pieces now. We've got the limit as h goes to 0 of f of x plus h, which is x plus h squared minus 2 times x plus h plus 4. All of that minus f of x, so minus the quantity x squared minus 2x plus 4. All of that divided by h. Now, by the way, for those of you that remember college algebra fondly, if I cover up this limit as h goes to 0, and I just see f of x plus h minus f of x over h, You might have seen that in your college algebra class, and you might have been asked to calculate difference quotients in that class. And you may have felt like, why am I doing this? Because this just seems like a very bulky calculation and I'm not really using it for anything. Well, you didn't really use it for very much there except for to practice manipulating symbols. But here, you want to be good at doing this. So that's why you did this in your college algebra class. Okay, so here's our limit as h goes to 0. We're hoping to simplify the numerator and eventually pull out an h and cancel it with the h in the denominator. So what's one thing that we can do?
Distribute the negative in the second part of the equation on the
Okay, we can distribute this negative through in the second part.
Square x plus h.
Okay, we can square out the x plus h. Okay.
Also 2 into x plus h.
Yeah, and we can also distribute this negative 2 into the x plus h.
What's wrong with that?